In this video, we'll be looking at 5.3, zeros of a polynomial. Definition, zero. A zero is an input value, for our function that maps to zero. And by input, for input, just in our generic is x. It's an x value that maps to zero. Said another way, a zero is an x-intercept. You can think of a zero as being an x-intercept. If we were to look at a graph of some polynomial, let's say that it looks like this. I see that we have x-intercepts here, here, and here. Perhaps this value over here is 4, 0, and this value here is -1, 0, and this value over here maybe is -5, 0. Well, all these x values, -5, -1, and 4, we consider those zeros because they're all x values that pair with a 0 for y. That is, if this function here, if we called it f of x, if this function is f of x, I know for sure that f of -5 would be equal to 0, and f of -1 is 0, and f of 4 is 0. These values here are all zeros. They are inputs that have a corresponding output of 0. So a 0, in shorthand, it's an x-intercept. All right. Remainder theorem. Remainder theorem. The remainder theorem states if polynomial p of x is divided by x minus r, this is some binomial factor, the remainder is p of r. There is a proof of this theorem, proof on page 359 of your ebook. It's the first page of this 5.3, but I'm going to show a concrete example that may help you understand, may clarify this. Let's say that our function, or our polynomial p of x, is x squared minus 4x plus 5, and we're going to divide that by the factor divided by x minus 2. Okay, well, writing this as a quotient, I would say this polynomial, I'm going to take my polynomial x squared minus 4x plus 5, and I'm going to divide by x minus 2 using the long division that we used in our previous section, divided by x minus 2. All right, so x goes into x squared how many times? X times. So x times x is x squared. X times minus 2 is a minus 2x. Now I can subtract. By subtracting, I'm going to change my signs and then add. So change. Adding, that cancels. Negative 4x plus 2x is a minus 2x. Bringing down my 5 plus 5. X goes into minus 2x minus 2 times. Negative 2 times x is a negative 2x. Negative 2 times negative 4 is a minus 4. Pardon me, plus 4. Negative 2 times negative 2 plus 4. Changing my signs and adding. This goes to 0. 5 minus 4 is a 1. Okay, this is my remainder. Okay. In terms of my quotient, I would write the remainder over my divisor. I would say that I would add 1 and then put it over my divisor, which is also coincidentally x minus 2. But the bottom line here is that the remainder is 1. Well, what my remainder theorem says, if I evaluate P of R, that is, in this case, if you'll notice, x minus R, in our case, we're dividing by 2. So what we're trying to say here is this value R, you see R is 2. R is 2. So what my remainder theorem says, if I look at my polynomial at that value, if I look at P of R, it is supposed to be my remainder, which is 1. So the remainder theorem says if I evaluate my polynomial at that value R, it should yield 1. Well, let's see if it does. So my P of x, my polynomial is x squared minus 4x plus 5. And we are hoping that when I substitute 2 in place of this, that it's going to yield 1. So does P of 2 map to 1? 2 squared minus 4 times 2 plus 5. Please let this be right. We don't want to break mathematics. 4 minus 8 plus 5. Well, that's 4 minus 8 is a minus 4 plus 5. That's 1. P of 2 is indeed 1. So what we see is when we divided by this x minus 2, this value 2, when we substituted it into our function, it produced the remainder. Well, why is that significant? It is significant for this next theorem, which is really a corollary, an outcome of the previous one, the factor theorem for polynomials. Here's the big one. Factor theorem. THM in math is an abbreviation for theorem. Factor theorem for polynomials. The factor theorem says if x minus r is a factor of P of x, that polynomial, P of x here is just a polynomial, then P of r will be 0. And in fact, this is an if or only if. It works both ways. If P of r is equal to 0, then x minus r is a factor and in the direction that we've stated it here. So looking back at this previous result, we knew previously if we divided by some factor and we got 0 here, then indeed this factor was a factor of that polynomial. So this is a natural consequence of that. If we take this value and it maps to 0, there was no remainder. Thus, this factor must have divided my polynomial evenly. And we'll see an example of that shortly here in our XYZ homework. All right, looking at a couple of examples from our XYZ. This first one is like number 1 or 2, perhaps. Yours may be shuffled up a little bit. It says, find P of 3 by substitution and by synthetic division. Well, we haven't studied synthetic division. If you want to look at the examples of synthetic division in our text, you can. It's a shorthand method of our long division. But here we can simply find P of 3 by substitution. So if P of x is 4x cubed plus 4x squared plus 4, and I want to find P of 3, I'm simply going to substitute 3 in place of all those x's. And I trust you can handle that with your calculator, or maybe even in your head. 3 needs to go there. So 3 cubed is 3 times 3 times 3, that's 27 times 4. I believe that's 108. 3 squared is 9 times 4 is a 36 plus 4, and that's 40. I believe this will be 148. Forgive me if I made a arithmetic error there, but I think you can handle that. Simple substitution on the first couple. All right. Next. It says use the factor theorem to answer the question below. Is x minus 3 a factor of 2x cubed plus 9x squared plus 4x minus 5? Well, remember what the factor theorem says. The factor theorem says if you have x minus 3, if something like x minus r is a factor, if that's true, then that function value, p of that value r, will go to 0. Said another way, this is my x minus r right here, okay? In this case, r would be 3. R is 3. If our function, if f of that value goes to 0, then x minus 3 is a factor. Okay, so all I'm going to have to do is just substitute 3 into this and see if it indeed pairs with 0. Let's think about why that is the case. You may remember from our solving by factoring that if we had a whole lot of factors and they were set equal to 0, then each one of them individually could be set equal to 0. And that's what we're saying here. If you set x minus 3 equal to 0, you would get x is 3, and that's what this value is. This value 3, it is a 0 of the function. All right, so essentially we're turning in this polynomial into a set of factors that would be x minus 3 times some other factors. But in this case, this is not going to map. If I find this function, I'm going to call this my f of x. So here, f of x is 2x cubed plus 9x squared plus 4x minus 5. I'm finding this f of 3. So 2 times 3 to the third plus 9 times 3 quantities squared plus 4 times 3 minus 5. Well, you don't even have to do the arithmetic. This clearly is going to be more big positive, 12 minus 5, not 0. All right, this is not 0. F of 3 is not 0, thus x minus 3 is not a factor. Since it's not 0, x minus 3 is not a factor. Factor x cubed plus 2x squared minus 9x minus 18. What I'm going to do to find the other factors of this polynomial is simply divide by this x plus 2. So I'm going to divide x plus 2 into x cubed plus 2x squared minus 9x minus 18. I know it's going to go in evenly. That is, the remainder will be 0 because it says x plus 2 is a factor. X into x cubed, x squared times. X squared times this one gives x cubed. X squared times 2x is a plus 2x squared. All right, subtracting. 0 and 0 there. So now I can bring down my minus 9x. X goes into minus 9x, minus 9 times. Minus 9 times x is a minus 9x. Minus 9 times plus minus 9 times plus 2 is a minus 18. Change. Adding, I get 18. And that will cancel with that 18 I bring down. So I see this is it. There is no remainder. So what I see is I have x squared minus 9. That's my other factor. So this polynomial is equal to x plus 2. Here's what we're saying. X cubed plus 2x squared minus 9x minus 18 is equal to this factor we already knew, x plus 2, and this new binomial is x squared minus 9. And I'll show that they are equal to each other. X times x squared is x cubed. X times minus 9 is a minus 9x. 2 times x squared is a 2x. And 2 times minus 9 is a minus 18. Well, hopefully you realize this is a difference of two squares. So this x plus 2 stays the same. And x squared minus 9 factors into x plus 3, x minus 3. So this would be my final answer. All right. So if they give us one of the factors, we simply divide our polynomial by that factor to find this other polynomial factor. And if it can be factored some more, we do so. All right. Last example, find all the polynomial solutions to 12x cubed minus 41x squared plus 12x plus 9 equals 0 if x equal 3 is one solution. What they're trying to say is that this value 3, this is a 0. This is a value when x is 3, y is 0. Said another way, the function value at 3 is equal to 0. 3 pairs to 0. Well, what that tells us, if x equal 3 is a solution, by our factor theorem, this corresponds to the solution, to the factor x minus 3. This makes perfect sense because if x equals 0, doesn't x minus 3 equal to 0? Well, this is going to be a factor of this polynomial. So I'm going to divide this polynomial by this factor. Here I go. I'm asking x minus 3 divided into 12x cubed minus 41x squared plus 12x plus 9. All right, one more time. Since we knew x was equal to 3, that's one of the solutions. I know that x minus 3 must be a factor of our polynomial. Okay, so I'm simply going to divide this polynomial by x minus 3. So x will go into 12x cubed, 12x squared times. Simply this term divided by that one is that one. Now multiply. This times this gives 12x cubed. 12x squared times minus 3 is a minus 36x squared. Change the signs and add. This is a minus 5x squared. Bringing this down is a plus 12x. Now x into negative 5x squared will be a minus 5x times. This one times this one becomes minus 5x squared. Minus 5x times minus 3 will be a plus 15x. Changing the signs and adding. 12 minus 15 will be a minus 3x. Bringing down my plus 9. X goes into minus 3x minus 3 times. Minus 3 times x will be a minus 3x. And minus 3 times minus 3 will be a plus 9. And you can see that will go to 0. No remainder, which we knew was going to be the case. So this is my other polynomial. Thus, if I want to find my other solutions, I now need to solve. Here's what we have. We have this times this is equal to 0. We have x minus 3 times 12x squared minus 5x minus 3 equal to 0. All we have done is changed this polynomial into these two binomial factors, because we knew, since x was equal to 3, we knew x minus 3 was one of the factors. We divided the big one by this one and got this other one. Well, we already have this. We've already set this one equal to 0, x equals 3. Now we need to deal with this. How can we set this equal to 0? Well, we could factor it using the big X method. We could use the quadratic formula. We could use completing the square. So let's see if this thing will factor. Coming over here with my big X. In the top is b, negative 5. In the bottom is a times c, negative 3 times 12 is a negative 36. Since this is a minus, one's a plus, one's a minus. I need numbers that multiply for 36 but will subtract essentially for 5. It's going to be 9 and 4. Since it's a negative, 9 will be there and 4 here. Okay, so still have our x minus 3. We're going to have x plus 4 and minus 9. But lastly, we must divide by this a term, dividing by 12. 3 goes into both of these. This reduces to 3 over 4. And 4 goes into both of these. This reduces to 1 over 3. I can write my denominators as coefficients. Okay. So we have x minus 3. That's my first factor. 3x plus 1, that's my second factor, and 4x minus 3. That's my third factor. Now I could set both of these equal to 0. We already set that one equal to 0. Now I can set 3x plus 1 equal to 0, solve that, and separately 4x minus 3 equal to 0, and solve that. This would be x is 3/4. And this is x is a negative 1/3. These are the other two solutions. All right, so that problem, a little bit to it, but I think we can, I think you'll be able to get there if you just look at it step by step. And that concludes this video.